Question 24. M equals the square root of s divided by t, where s is equal to 3.47, correct to 2 decimal places, and t is equal to 8.132, correct to 3 decimal places. By considering bounds, work out the value of m to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. It's a 5-mark question because we're going to be needing to do quite a bit of calculations in this one to back up our answer. Now, bounds are a way of showing what the possible values could have been for each of these values before they were rounded. So if we look at s, the highest value, which is known as the upper bound, if this was rounded to 2 decimal places, this means this technically could have almost gone halfway up to 0.48. So that number would be written as 3.475. Now, while technically 3.475 would actually have been rounded up to 3.48, sorry, you're not going to write down 3.47499999999999, so that is a reasonable upper bound. In similar fashion, the lower bound would be halfway towards the number below it, which is 3.465. Because this number could, or anything above it, could have been rounded up to 3.47. Likewise, if we look at the letter T, the highest number this could have been would be halfway towards the next value. So instead of 8.132, we're looking for a number which is halfway towards 8.133, which would be 8.1325. To find the lowest number, we want to find halfway towards the number below it. So halfway between 0.132 and 8.131 would be 8.1315. So these are the possible numbers that we could have been given. Anything between these two values for s and anything between these two values for t. So if we're going to substitute these into the formula, we want to find out what the biggest possible value could be and what the smallest possible value could be, because that would give us a good indication of what m could actually be. So to find the biggest answer, we want the biggest number on the top and the smallest number at the bottom. So for one possible answer, we're going to take our upper bound for s, so we're going to find the square root of 3.475 and divide that by the smallest number at the bottom, which will be 8.1315. So if we put this into our calculators, 3.475, square root that value, divide that by 8.1315, I get 0.2292486 with a bunch of other numbers afterwards. So that's the biggest, I think, that the value could go to. So to find the smallest value of m, we need to have the smallest number on the top divided by the biggest value at the bottom. So if we look at our lower bound on the top, we're going to find the square root of 3.465 and divide that by the biggest value at the bottom, which will be our upper bound for t, which is 8.1325. Going back to our calculator, we have 3.465, square root it, divide by 8.1325, which is equal to 0.228 8, 9, 0, 3, 8, and a bunch of other numbers. So they're the highest and the lowest possible values that this calculation could give us. We're asked to say, by considering bounds, work out m to a suitable degree of accuracy. So if we wanted to give a number that both of these could be rounded to, we could say 0.2, 0.23, but also it could go to 3 decimal places, which would be 0.229 in both cases. After that, the first number would be 0.2292, the second one would go 0.2289, which are completely different. But both of these values can be rounded to 3 decimal places. So for a final answer for here, we're going to say m is equal to 0.229, because the maximum and minimum values for m can both be rounded to this with 3 decimal places.